Hello, so we're back, and this time we have kind of nice laptop to repair. Huawei, we have an i5 10 Gen, and I know this is a classic issue with the charging port. I know that, but it's not the case here. Pressing the power button, the laptop is just dead. But let's check the customer email. So the customer is saying, "Hi, Sorin, you helped me with a gaming laptop before. Hopefully you can help me with this one. Huawei, it blinks when you plug in the charger. And if you unplug the battery, the light stays on when you plug the charger." So what the customer trying to say is doing some weird things, but the laptop is still not working. I would say let's plug a charger and see what it's doing. We have the power meter here, plug in the charger, and the meter it is coming on, so we don't have a charging port problem. It's taking 2.3 amps, check there, with 4.5 volts. My meter is getting hot. Insane amount of current for 5 volts. Yeah. I will say let's open the laptop and try to have a look inside. It is strange the customer is saying if you unplug the battery, then the light is staying on the charger. So this current is going actually into the battery. Interesting. I mean, this is kind of like a unique video. There are not that many videos repairing Huawei which doesn't have a charging port issue. So the laptop, it's open. Yeah, that's a classic motherboard. So let's check what the customer is saying. So if we are unplugging the battery, if we are plugging the charger, yeah, same, exactly the same, 2.4 amps with 4.5 volts, and I can't see any light here. Kind of strange. Now we do have a bunch of capacitors here. Here are like power supplies and their capacitor. Let's check the main power rail just to be sure it's not shorted. So the main power rail is not shorted, yeah? So the main power rail is not shorted. Then it's strange. Who is taking that much current? 2.4 amps. Because we unplugged the battery. So who is taking that much current? Strange. And I want to know badly what is taking that much current. I will say, let me get the thermal camera and let's have a look. I mean, somehow it is possible because we have a buck and boost converter. It is possible the power supply is boosting the 5 volts to like 19 volts, or not 19, probably the battery voltage. Then the board is starting. It is possible. But very unlikely. Does mean the PD controller is faulty, it's not negotiating the voltage. But let's see. So we plug the charger, 2.4 amps, and the laptop is coming on. I mean, one second, what is here? I can see heat on this side of the CPU. You know what? Let me take out the heatsink. I'm very curious. So the heatsink, it's out. The chipset, that's crazy. So the chipset, it's actually there. Yeah, it's proper hot. It's proper hot. Let me clean it. The chipset is hot. The chipset. Yeah, so what you see there is a dead chipset. You can see, you can't see. Anyway, the heat, it's exactly on the corner. It's not spread it all around. How you see on the camera, it's exactly on the corner. Check there. Yeah, that sucks. So what we have here, we have a faulty chipset. Yes, so the laptop, it is working normally. I mean, probably the main power rail. Let's check the main power rail. So at the input, we have like 5 volts, 4.5 volts. So from 4.5 volts to 7.3 volts, yeah, that power supply is boosting the voltage. Then from there, the CPU is cold. I mean, the chipset is getting that kind of power. Sadly, it's nothing what we can do. How the chipset died? Who knows? Hard to say. You're pressing the power button and obviously nothing happened. Plug in the battery, not sure if it's charging. No, the current is not going up. The battery, we have 4 volts. Yeah, let's push some current into the battery. Good. So we are pushing 2.8 amps into the battery, and the battery voltage is, check that, it's 11 volts, but the current on the meter goes down to 0. Because I'm supplying the necessary current for the chipset from the power supply. Yeah, I need like a ground. Like a good ground. Yeah, that's a good ground. And now it's taking only 500 milliamps. Let's charge the battery a little bit. Let's raise the voltage. Let's raise the current. Yeah, we have like 3.5 amps. Pretty strange because the PD controller isn't working. Because what is shorted on the chipset probably is the RTC line, which is also the LDO for the EC chip. Yeah, that can make sense. And because we have no LDO, then the EC chip is not speaking with the PD controller. I'm just assuming. We can check that. So the power button, on the power button we do have some voltage. We have like 3.3. Okay, that's interesting. Battery voltage 10.5, which is too low. We can fix that. Kind of strange. Why the CPU is not getting hot? The chipset is not getting hot anymore. Pressing the power button and nothing happened. Now, if the laptop will take current, I will see the voltage drop on the power supply because we don't have a current limit. 1 second. Now we have a current limit. Pressing the power button and no, nothing happened. Holding the power button down. No, nothing happened. Pressing the power button, nothing happened. Nothing happened, but the chipset is not getting hot anymore. How? We done nothing. Okay, let's unplug the battery. Yeah, it's still taking 2 amps, the chipset. Yeah, probably now it's taking current from the battery. So the voltage is getting dropped on the battery. Yeah, 10.7, and it's going down. Yeah, the chipset it is getting hot. But the PD controller seems to be working. The EC chip. Trying to find like 3.3 here. No? On the keyboard? No. BIOS chip? No. I mean, I'm trying to find a connection between the non-working PD controller and the EC chip. I mean, why? We have the EC chip. We have some resistor around. I'm trying to find like a pull-up resistor. We have a capacitor here, and we have 0 volts. Huh? But why we have 3.3 on the power button then? Here we have 0. Here we have 3.3. So 3.3 is present here. That must be the LDO voltage. But it's not present on the AC chip. That's interesting. Let's check the AC chip. So the AC chip, looking good. Then I don't know. The voltage is present here. But still, we do have 3.3 here. .3. I'm not sure what this is doing. 1.6. 3 volts here. BIOS, we have 0.4. Why we'll have 0.4 on the BIOS? Yeah, I know. I know what you're thinking is because the voltage is taken by the chipset on the RTC line, real-time clock. Yeah, most likely. And it's taking out the LDO for the chipset and BIOS. We have like 0.4 volts on the BIOS. Yeah, that sucks. On the AC chip, yeah, I can see the AC chip has some power still. I mean, not sure what is getting hot here, but I'm assuming it's a current sensor. I mean, exactly here. So that thingy, that diode actually, that diode is getting hot. You know what? I want to disconnect the screen on this point. Let's disconnect the screen. That's water damage. Check the green thingy. Yeah, that can be a reason why the laptop died. Why the chipset died, actually. But you know what is strange? It's strange because the chipset is getting very hot without the battery. And I'm just asking myself why. So here we have 0, and here we have 0.4. Huh? What is this? This probably is the backlight, I'm assuming. Why this diode is getting hot under the thermal camera? 0.4, and here we have 0. Where this is going? Let's clean the screen quickly. Yeah, you can clearly see the green thingy. It's actually liquid damage. Okay, so we clean it. Let's check what's going on with that diode. So what's the story with the diode? Why the diode is getting hot? Diode is not burned. But with the ground, here at the plus of the diode we have ground. Here is fine, but here is ground. Why here is ground? Here we have a capacitor. On the other side of the capacitor we have ground. But if here is ground, why here is beeping? That's my question. So we have both grounds, the ground on the both sides of the capacitor. So what I'm gonna do, I'm gonna come with the power supply, I'm gonna lower the voltage because there is no key. You have ground on the both sides of the capacitor and the diode is getting hot because obviously cannot supply voltage to that power rail. I'm gonna lower the current and that will come exactly here, and it's taking 700 milliamps, 800, 900. 1 second, I will switch the scene. Yeah, let's see, 900, 700, 700, 800 milliamps. I'm curious what is taking the current. And what is taking the current? Huh? I have no idea. Okay, this is something strange. I mean, something it is taking 800 milliamps, you know? I mean, and you have 0 ohms. No, something must be wrong there. Something must be very wrong there. So one more time. At the plus of the diode, which is here. And now it's taking no power. It's taking like 10 milliamps. That's sick. That's crazy. What I did, I took out the heatsink. That's all what I did. No. It's taking 900. Oh, yeah, that makes sense. Check there. Actually, the chipset on the other corner. You can see the chipset on the other corner is getting hot. Yeah, that's why. That's why. Yeah. So what happened? A drop of water came here. This is like a thermistor, and I'm assuming it's on the 19 volts. But just to prove the theory, here we have 3 pins on one side, you can see. So that means the 3 pins from here are on this side of the connector, here. That means the 3 pins are going straight to my thermistor. Yeah, 0 ohms. Now the voltage here is the battery voltage. So if I plug this, let me check to be sure. No. No. Okay, so the voltage is switched on by something. But that doesn't change the problem. Um, it was a drop of water here. And the drop of water, yeah, you have in this area, this small area, yeah, you have 19, no 19, you have more 11.4, 12 volts. So you have 12 volts. Then you will have a power rail which is going to the chipset, which most likely is like 3.3 or even lower. Now, when you have a drop of water, does mean your chipset, it will take that 12 volts. And that can explain how this chipset got faulty. Sadly, it's nothing what we can do. I wish I can do more. You know what? I hate manufacturers. They use this kind of like Apple. Like they have that screen connector with the main power rail next to like to data lines or 3.3 or whatever. Same here. I mean, you have like in a small area, you have 19, then you have a truck which is going a power rail for the chipset. Obviously, that's very obvious. If you have a drop of water, you will kill the things. How the other manufacturers are doing? I mean, they are using 12 volts. Anyway, the backlight voltage they are using. Then the next pins are ground. So in case a drop of water is there, the current it will goes from plus to ground because you have the next pin at ground. But I never seen like a truck which is going to the chipset near to these points, this high voltage power rail. Not sure what they did something like that. I mean, when you design something like that, yeah, you cannot. That's the first thing what you are checking to don't have like high voltage power rail to data lines or low voltage power rails because first drop of water you will kill it. Well, I'm gonna stop here. I will say thank you for watching. Like, subscribe if you like the video, and see you on the next one. Bye.